So I'm actually a medical oncologist by training. So I do see and treat patients, and I specialize in the tumor of the brain and the spinal cord. Historically, cancer has been studied using molecular techniques. We came to realization that using the traditional approach, although it's very powerful and it's get us where we at today, but it's very inefficient. So we use the computer to help us identify genes that are very critical for cancer, for them to grow, for them to resist therapy, and then for them to evade the immune system as well. And so that's what we have been focusing on over the last 5 years, where we develop our own AI technology in the lab.
The Invention is a way to take cancer cells in a tumor and actually convert them to an immune cell type that will prime the body's immune response, or I should say the immune system, to actually attack the tumor directly. So not only is the technology eliminating cancer cells, it's also turning those cancer cells into the therapy itself.
We basically mine that data using AI technology to identify what we call master regulators. So these are the genes that are connecting with each other, and they regulate a large numbers of other genes. Could be hundreds, could be thousands. And what they do is that they create this network of master genes that promote the survival of cancer cells, promote their ability to resist therapy, and also their ability to evade the immune system.
Theoretically, this could treat tumors that are in difficult to operate locations or inoperable. The inventors specifically are looking at glioblastoma, GBM, which is a brain cell tumor.
So we have developed multiple AI technology, and then from there we have many derivatives of the technology where we use the technology to identify master regulators of different processes, not only in cancer, although that's the big focus in the lab, but we also focus on other disease phenotypes as well. For example, in organ failure, where we focus a lot on regenerative medicine.
This therapy will provide a path to treatment that may not otherwise be available. Taking those cancer cells and converting them to the immune cells, it's just a very novel approach and has the potential to really change the way we look at cancer. Therapy, instead of applying drugs, we're actually using the cells that are already there in the tumor to become the therapy, and recruiting the body's immune system to actually attack those.
So that's the sort of the foundation of our lab, where we use AI technology that we develop, and then use them to analyze genomic data of cancer, of any particular disease, and come up with a list of master genes that are very critical for that disease process. And then we develop therapy to either promote that process in the case of regenerative medicine, or to block it in the case of cancer to prevent cancer cells from growing.
So congratulations, David and Son. I'm happy to have nominated you for Invention of the Year. Your work is always inspiring to me. It is impactful and helpful to the patients, and I am honored to work with you both.
Even though I'm nominated for this award for this invention, but this invention and all the invention in my lab is a collaborative effort of the entire team. Without us working together, this wouldn't be possible. And lastly, I'd like to also thank my departments, my department chair, Dr. Ho, my former chair, Dr. Freeman, and also Dr. Dwayne Mitchell, who have actually provide me with all the supports that we have needed over the last 5 years to translate many of this technology into potential therapy for patients. And last but not least, of course, the OTL. Without their help, without Rachel Harding, without Zahara, we wouldn't be able to patent many of the discoveries that we have created over the last 5 years. So thank you very much.